Good morning, my dear students of Standard 9. Welcome back to the chemistry class. Dear students, we are talking about chapter 6 from your chemistry book. Today, in this class, I am going to discuss a new topic, that is stoichiometry. Dear students, this is completely new topic for you. Do you know what is stoichiometry? Stoichiometry is the branch of the chemistry that deals with measurement of products from amounts of reactants and measurements of reactants from amount of products. This is stoichiometry. That means in this branch the amount is measured from product to reactant and also from reactant to product. That means in a chemical reaction, if there are more than one reactants and also if there are more than one products, then from any of the amount you can calculate the others. From one reactant to another reactant, from one reactant to all products, and also from one product to all reactants. This is stoichiometry. Today in this class we will discuss about this. Look, here in this reaction X is reactant, Y is product. That means you can calculate the mole number of Y from X and also X from Y. And if you can calculate the mole number of X and Y, then from there you can calculate volume of X, volume of Y, mass of X, mass of Y, and also particles or molecule number of or atom number of X and also particles of Y. Now look this reaction. Here nitrogen and hydrogen, they produce ammonia. After balancing the reaction, we can tell that here 1 mole nitrogen and 3 mole hydrogen give 2 mole ammonia, isn't it? 1 mole nitrogen and 3 mole hydrogen give 2 mole ammonia. Now 1 mole nitrogen means what? 1 mole nitrogen means 28 gram nitrogen. 3 mole hydrogen means 3 into 2, that is 6 gram hydrogen, and 2 mole ammonia means 2 into 17, that is 34 gram ammonia. Now look, if I give you 28 gram nitrogen, then you can tell that from there you will get 34 gram ammonia. And also you can tell it that to react with 28 gram nitrogen, you need 6 gram hydrogen, because this mole number is fixed and 1 mole nitrogen reacts with 3 mole hydrogen, not more or less than that, and they produce 2 mole ammonia, not 3 or 1 or any other mole number. And also from there we can tell 6.02 into 10 to the power 23 molecules nitrogen react with 3 into 6.02 into 10 to the power 23 molecules hydrogen, and they give 2 into 6.02 into 10 to the power 23 molecules ammonia. We can measure the volume also, because all they are gaseous. So at STP, 22.4 liter nitrogen reacts with 3 into 22.4 liter hydrogen, and they give 2 into 22.4 liter ammonia. This is stoichiometry, and from there we can calculate any reactant or any product from the other reactant and product. Now we will do some problem from there. Look, how many moles of oxygen is necessary to burn 6 moles of magnesium completely? Here you have to calculate the mole number of oxygen that is needed to burn 6 mole magnesium. Here magnesium is burnt in oxygen, and what is produced? There is not written, but you know that when magnesium is burnt in oxygen, then magnesium oxide is produced. So at first When you will do the solution, write the reaction and balance it. Here 2 magnesium, that means 2 mole magnesium reacts with 1 mole oxygen and they give 2 mole magnesium oxide. This is the balanced reaction. And here there is given how many moles of oxygen is necessary to burn 6 mole of magnesium. No need to find out this product. Only here the reactants are needed. So here we can write 2 mole magnesium, 1 mole oxygen and 2 mole magnesium oxide. You can write it or not, no problem. So from there we can tell that 2 mole magnesium reacts with 1 mole oxygen. Now in unitary method we will find out how many moles of oxygen is needed to react with 6 moles magnesium. So to burn 2 mole magnesium completely, 1 mole oxygen is needed. Therefore, to burn 1 mole magnesium completely, 1/2 mole of magnesium oxygen is needed. So to burn 6 mole magnesium, 1 into 6 divided by 2 mole oxygen, that is 3 mole oxygen is needed. This is our required answer. To burn 6 mole magnesium completely, 3 mole oxygen is needed. Now look, when magnesium is burnt in atmosphere, then there are huge oxygen, but all the oxygen reacts with magnesium? No. For 1 mole magnesium, only half mole oxygen is needed. So this amount of oxygen is used in the reaction and other oxygen, they don't take part in the reaction. Now problem 2. What is the amount of sodium hydroxide needed to neutralize 156 gram sulfuric acid completely? Look, this is the reaction between sodium hydroxide and sulfuric acid. And we know sodium hydroxide is a base and sulfuric acid, it is an acid. So their reaction is called neutralization reaction. Here the amount of sulfuric acid is given. One reactant is given. You have to find out the amount of sodium hydroxide needed to react with 156 gram sulfuric acid. So at first write the reaction. Sodium hydroxide and sulfuric acid, they react and they produce what? Sodium sulfate and water. Because you know when base and acid react, they produce salt and water. And obviously you will balance the reaction. Look, here 2 mole sodium hydroxide reacts with 1 mole sulfuric acid and produce 1 mole sodium sulfate and 2 mole water. Now look, here only the reactants are given in the question. So we will write here 2 mole sodium hydroxide, 1 mole sulfuric acid, 1 mole sodium sulfate, 2 mole water. Here the amount, that means here the calculation, in this calculation the mass is needed. So we will put the molecular mass here. The molecular mass of sodium hydroxide is 40. So here 2 mole, so it is 80 gram, and the molecular mass of sulfuric acid is 98. So it is 98 gram. No need to put the molecular mass of these two because we have no need to find out them. Only we have to find out the amount of sodium hydroxide by using the amount of sulfuric acid. Now look, from this reaction, can we write 98 gram sulfuric acid neutralizes 80 gram sodium hydroxide? 98 gram sulfuric acid is needed to neutralize 80 grams sodium hydroxide. Here there is given 156 grams sulfuric acid is needed to neutralize how many sodium hydroxide. So here also we will do the unitary math. Here 1 gram sulfuric acid is needed to neutralize 80 divided by 98 gram sodium hydroxide. Therefore 156 gram sulfuric acid is needed to neutralize 127.347 gram sodium hydroxide. This is our required answer, because here you have to find out the amount of sodium hydroxide needed to neutralize 156 gram sulfuric acid. Now, problem 3. What is the volume of oxygen produced by the decomposition of 100 gram potassium chlorate at STP? Here, the reaction is the decomposition of potassium chlorate, and here the amount of potassium chlorate is given 100 gram. You have to find out the amount of oxygen, but the volume of oxygen, not the mass of oxygen. So at first write down the reaction, decomposition reaction of potassium chlorate. Potassium chlorate is decomposed to produce potassium chloride and oxygen. Balance the reaction. 2 mole potassium chlorate is decomposed to produce 2 mole potassium chloride and 3 mole oxygen. Here look, 2 mole potassium chlorate. Here the amount is in gram. So we will write the molecular mass of potassium chlorate and volume of oxygen. 2 mole potassium chlorate, 2 mole potassium chloride and 3 mole oxygen. Potassium chlorate, its molecular mass is 122.5. So 2 mole potassium chlorate, that is 245 gram potassium chlorate, and the oxygen 3 mole. Here the volume of oxygen you have to find out. So here I have written the volume of 3 mole oxygen, that is 22.4 into 3, that comes 67.2 liter. So now we can write 245 gram potassium chlorate gives 67.2 liter oxygen at STP. So 100 gram potassium chlorate gives how many oxygen? You have to find out this. By the decomposition of 245 gram potassium chlorate, 67.2 liter oxygen is produced. So by the decomposition of 1 gram potassium chlorate, 67.2 divided by 245 liter oxygen is produced. And by the decomposition of 100 gram potassium chlorate, we get 67.2 into 100 divided by 245. It comes 27.43 liter oxygen. That means by the decomposition of 100 gram potassium chlorate, 27.43 liter oxygen is produced. This is the required answer, 27.43 liter oxygen. Now this is the last math. How many molecules of carbon dioxide gas are produced by the combustion of 80 gram methane? Here look, here the combustion reaction of methane has to be written, because here you have to find out the molecule number of carbon dioxide gas produced by the decomposition of 80 gram methane. Decomposition not, by the combustion of 80 gram methane. Combustion means methane reacts with oxygen, and you know that when hydrocarbon is combusted, when hydrocarbon reacts with oxygen, then they produce carbon dioxide and water vapor. So here I have written the combustion reaction of methane, methane plus oxygen, and the products are carbon dioxide plus water vapor. And after balancing the reaction, we get 1 mole methane reacts with 2 mole oxygen, and they produce 1 mole carbon dioxide and 2 mole water. Look, here we need 2 things. One is carbon dioxide and another is methane. Now 1 mole methane means 16 gram methane, and carbon dioxide, 1 mole carbon dioxide. Here we have to find out the number of molecules. So 1 mole carbon dioxide equal 6.02 into 10 to the power 23 molecules carbon dioxide. So now we can write, after combustion of 16 gram methane, 6.02 into 10 to the power 23 molecules carbon dioxide is produced. 16 gram methane produces 6.02 into 10 to the power 23 molecules of carbon dioxide. Therefore 80 gram methane, so at first we will write 1 gram methane produces 6.02 into 10 to the power 23 divided by 16 molecules of carbon dioxide. So 80 gram methane produces 3.01 into 10 to the power 24 molecules of carbon dioxide. This is our required answer, because the question is how many molecules of carbon dioxide is produced from 80 gram methane. So the answer is 3.01 into 10 to the power 24 molecules of carbon dioxide. So dear students, today up to this, here I have shown 4 math, and I hope you can do this type of all math. Just one thing you have to remember, that is to balance the reaction is must. Without balancing, your math will be wrong. So to do this type of math, that means when you will do stoichiometry, you have to balance the equation. This is your homework. What amount of calcium carbonate should be heated to get 15 liter carbon dioxide at STP? 2 number math, to produce 25 molecules ammonia gas, how many molecules of hydrogen gas is needed? And 3 number math is, what is the volume of hydrogen gas produced when 90 gram zinc is dissolved into sufficient amount of sulfuric acid? So dear students, today up to this, goodbye everyone. Thanks to all.